Rain falls on a prune, and it swirls, and in swelling pushes up a lever. The lever presses down on an old flint lighter, which in turn lights a candle. The candle therefore boils water in a kettle, and the kettle, when it starts to steam, activates a whistle, which consequently scares a monkey, who as a result jumps on the swing, and the swing, like most swings, has great knives attached to it, yeah? And as the swing is rocking backwards and forward, it scythes through a string which is anchoring the balloon. So the balloon rises in the air. The balloon is also tethered to cage doors, and so the cage doors open, and little birds therefore fly out, and the birds are attached to the umbrella, and hence the umbrella. Okay. There we are. Now you can see that there is a logical sequence of events, and I'm sure, although we can't usually identify it, such would apply to gene activation. However, say the monkey wasn't scared. Say the birds, thank you very much, like being in their home cage. Then clearly this sequence of events is not completely 100% reliable. Many things could change. Other things could scare the monkey, not the rain falling on the prune, and so on. So I don't want to labour this point too much, but I hope you can get the idea that you do not have one gene making one protein corresponding to one function, any more than you have one brain area corresponding to one function. What you have is a subtle interplay. Any one gene can make 30, 40,000 different proteins. They in turn will act on all those different brain areas, on all those different circuits, doing many, many different things. And we only have a very vague idea in most cases of that connection. So let me give you an example of even when that's not the case, even when we do have a very strong idea of the connection, very unusually, between a gene and a malfunction, even there, things are not as easy as you might think. Let me show you the example. This is a healthy brain. Well, it's not healthy anymore. The person has died, but then what's healthy? And either side here, I want you to focus on this bit, yeah? These areas. These are naturally occurring so-called ventricles, which are formed during embryogenesis, during development. Focus on the tissue either side of those holes, and compare that with this brain. And as you can see, the holes are much enlarged due to loss of the tissue on the adjacent sides of the holes. This is a brain from someone who had a disease called Huntington's chorea, which I'm sure everyone's heard of. Chorea after the Greek for dance, because the patient presents with wild, involuntary flinging of the limbs in a grotesque form of dancing. Now, the reason I'm suddenly talking to you about Huntington's chorea is this is one of the few, in fact, the only brain disease I know that does relate to one bad gene only. Only one rogue gene. So this might seem to be a counterexample to what I've just been saying. Here we do know. One bad gene, one malfunction, absolutely no question. But even here, and even in mice, we can see that the situation can be subverted. It can be subverted by the environment. So here we have so-called transgenic mice. That's to say mice for whom the gene has been deliberately tweaked to give them the mouse equivalent of this movement disorder. Now that's quite easy to evaluate in rodents because you can give them little tests and score their movements in various little tests. The higher the score in this case, I'm going to show you, the worse the movement. So why am I even telling you about this? Because if it's one bad gene, bad movement, you have these mice with the bad gene, they're going to have a bad movement surely. Why am I even bothering to mention? The reason is that even here, even with little mice, even in the rare example of a single gene disorder, we can see nurture trumping nature, the environment making a huge difference. So let me show you this, to my mind, astonishing experiment that was published now 8 years ago. Here you have the mice kept in standard lab conditions, relatively normal sized cage. Compared to their counterparts, and this is done to scale, in a much bigger cage with ladders and wheels. This is a so-called enriched environment. Now, enriched for a mouse doesn't mean to say they come here and look at fine art. It means that they have ladders and wheels and little food hoppers in a way that their counterparts do not. So in this experiment, the idea was to see, could an enriched environment make a difference to mice who are genetically destined to have Huntington's chorea? Bear in mind, the higher the score, the worse the movement. So let's look and see what happened. Well, here you can see, as always in science, we have to do the control. The red group here are the animals that had not had their gene tweaked. So you don't have to look around. All you'll see is a flat line. Don't worry, there's nothing there. It's a flat line showing no score because the animals were moving perfectly well. However, their counterparts here in the standard housing